We will discuss this problem, which is asked in the civil services examination. The question is like this, that determine the distance from the nucleus at which the electron is most expected in the hydrogen atom in its ground state. Here it is given that the normalized radial function for hydrogen-like systems is R101s is equal to 2 z upon a naught to the power 3 by 2 into e to the power minus rho by 2, where rho is 2zr by n a naught, and a naught is the first Bohr orbit radius. Other notations have their usual meanings. So in order to solve this, we will write R101s is equal to 2 into z upon a naught to the power 3 by 2 into e to the power minus rho by 2, as it is given here in the question. Similarly, we are writing here, and here we are substituting the value of rho, which is given to be 2zr by n a naught. So when doing this, we see that R101s is equal to 2z upon a naught to the power 3 by 2 e to the power minus 2zr divided by 2n a naught. Simple substitution of rho in this equation. Now for hydrogen atom in the ground state, n is equal to 1 because it is first Bohr orbit, and z is equal to 1. For first, in the ground state, the electron remains in the first orbit, that is n is equal to 1. And atomic number of hydrogen is also 1, so z is equal to 1. Now, R101s is equal to 2 into z upon a naught to the power 3 by 2 e to the power minus 2zr divided by 2 in a naught. Here 2 and 2 cancel out, and simply we get R101s is equal to 2 into 1 upon a naught to the power 3 by 2 e to the power minus r by a naught. Here 1 and 0 are indicating the values of n and L. N is the principal quantum number and L is the azimuthal quantum number. Now the wave function for hydrogen atom. Here we are getting the radial wave function R10, and we have to write the wave function for the hydrogen atom. So it is psi is equal to RR theta theta phi phi, because psi is the function of radial wave function and the angular wave functions theta and phi both. Now we see that theta theta is equal to 0 and phi phi is also 0. Why? Because the 1s orbital is spherically symmetrical. So angular wave functions, they become 0. So our psi is equal to RR. Now psi is equal to, we are putting the value of RR, that is 2 into 1 upon a naught to the power 3 by 2. It is given here. 2 into 1 upon a naught to the power 3 by 2 e to the power minus r by a naught. Now we are squaring this equation both left hand side and right hand side. So psi square is equal to 4 into 1 upon a naught to the power 3. We are squaring this, so 2 and 2 cancel out, becomes 3 e to the power, here power becomes 2 into r minus 2r divided by a naught. Now the probability distribution function for hydrogen atom is given by F is equal to psi square into delta. What is F? This is the probability distribution function for hydrogen atom, and it is given by the square of the wave function into the volume element. What is this volume element? If we are representing the hydrogen atom like this, its this is the electron, and its distance of electron from the nucleus is r. Then what is this volume element? Is the volume of a spherical shell, that is of the thickness dr. So what is the volume of this spherical shell? That is the surface area of this spherical shell, that is 4 pi r square into the depth, that is the thickness of the shell. So it is dr. So 4 pi r square dr becomes the volume of this volume element. And we are multiplying chi square by this. So probability distribution function becomes chi square into 4 pi r square dr. Now putting the value of chi square here, which we had calculated earlier, 4 into 1 upon a naught whole cube e to the power minus 2r by a naught into 4 pi r square dr. Now probability of finding electron is maximum when df by dr is equal to 0. Then we are differentiating, we have to differentiate this equation with respect to r. So df by dr is equal to ddr of 4 upon a naught cube into 4 pi r square into e to the power minus 2r by a naught dr. We are solving this simply. So constant things come, they are coming out of the derivative function. So 16, 4 figure 16, 16 pi by a naught cube into ddr of variables are here inside this bracket, r square into e to the power minus 2r by a naught. So when we differentiate this much of values, what we are getting, 16 pi by a naught cube is equal to 2r. By doing partial differentiation, differential of r square is 2r into e to the power minus 2r by a naught plus r square into derivative of this exponential term. So it is minus 2 by a naught into e to the power minus 2r by a naught. So ultimately it becomes equal to 16 pi by a naught cube into 2r into e to the power minus 2r by a naught minus 2 into r square into by a naught into e to the power minus 2r by a naught. Now rearranging the terms here, we are getting the common things we are taking out of the bracket. So what we are getting, 16 pi by a naught cube into 2r into e to the power minus 2r by a naught into 1 minus r upon a naught is equal to 0. So this is the left hand side is the product of two factors here, but if LHS, whole LHS is equal to 0, either this much is 0 or this is 0. But why? Because R cannot be 0. R is the distance of the electron from the nucleus, so it cannot be 0. So what is 0? 1 minus R upon A. So putting 1 minus r upon a naught is equal to 0. What we get? R is equal to a naught. Hence, the required distance, which was asked in the question, is equal to the first Bohr orbit radius a naught.